Good evening, everyone. Welcome to this Embedded System Design Masterclass series. I warmly welcome you to the session. Thanks for coming and thank you for your time. And I would also like to thank the Andhra Pradesh State Skill Development Corporation for their support for this program. So today's topic is DC motor control using PIC microcontroller. So far we have covered up 25 days. Like we started the series with the introduction to embedded system design, and we cover up some basics on embedded system design and on IoT and autos. On the second week, we have covered up 8051 microcontroller series. On the third week, we have covered up the ARM7 LPC 214, right? And the fourth week, we have covered up LPC 4088 series. And this week is PIC. Almost we have completed this week, so only one more week to go. So I hope you have enjoyed the session so far. And thank you once again for this for coming on this day. And today, you are going to learn the basics of pulse width modulation, how pulse width modulation works, what are the components required for this project. Okay, what are the components, what are the hardware required for this project, the schematic design, how you want to connect the circuits, like how to connect the DC motor, the driver circuit as well as the switches, and what is PWM and what are the registers involved in PWM, and how to write the program for that. So these are the things which we will be covering up today. So before I go into the session, I'll give you a short introduction about Pantech and about me, and then we could go for the announcement. Then we could go for the session. Okay. So Pantech was started in the year 2004. We basically manufacture embedded motherboards like microcontroller boards, DSP boards, and FPGA boards. We do have a lot of lab equipments on both electronics as well as on electrical engineering. And we do manufacture a lot of sensors on we have brain computer interface sensors called BrainSense, where it could control robots using brain and switch on the home devices by using your brain. Okay, so we also have AI development boards, and we have a lot of algorithms on artificial intelligence on MATLAB as well as on the Python. If you want to know more about our products and services, just log on to our website pantechsolutions.net. So our vision is to help 10 million students to learn the technology in an easy way. So far we have covered up 1 lakh plus students on YouTube, and this year we have a mark of around covering up 9 lakh plus students on YouTube. So we have a lot of upcoming sessions on PCB design as well as schematic design and the autos. We have upcoming sessions on free autos and on NVIDIA platform, like artificial intelligence using NVIDIA platform. So much more sessions of that. So I welcome you to invite you to attend all those sessions and make use of it. About me, my name is MK Jeevarajan. I have given my introduction for the past 25 days. So if you want to connect with me, I have provided my LinkedIn link in the description, or you could get it from the previous on the day one video. You just you give me a connection request. I'm happy to connect and happy to help. So coming to the announcement, the attendance link will be available at 9 p.m. and it will be valid for 2 more hours. Like the minimum attendance required to get an e-certificate is 27 days, and you may get a waiver of 1 or 2 days. Even 25 days is enough to get the attendance, to get the e-certificate. So for internship candidates, no need to fill the attendance form, as it will be generated from the portal. So about the internship, we are on the final batch of internship. We have only 7 more days to close the internship. So where you will get 30 days of video coaching lessons and weekend live Q&A sessions for 6 months, and digital workbook download, internship certificate, and 10 plus projects and sample resume. You could get support through dedicated forums on WhatsApp, and you could download the PPTs, you could download the source codes, you could download the schematics for the projects, and private WhatsApp group access. All those things are available for 590, and after this series it will be around 999 rupees. Okay, it will be around 999 rupees. So if you wish to enroll, this is the right time. This week is the right time. The coming week is the right time if you want, if you wish to enroll. Like after that, the price will be increased to 999 rupees. So if you wish to use this internship, like if you wish to use this offer, like you could avail this offer and make use of it. I assure you, like this is the best course which you get at this value. Okay, so definitely it will help you on your career process. So let's start the day with a mindset lesson. So today lesson is about money, because most of the college education, like the school education, they don't taught about much on money side. Like they teach us on skill sets, but they don't have any they don't taught us on the financial part. Okay, which is very essential for your life. I want you to take any courses for that. Even if you take a courses, that would be that would be of great help for you in the future after getting a job, or like it for the lifelong. It will this course will be helping you for lifelong, because we all the end purpose of studying this course, or the end purpose of getting a job is to make money. Okay, to make money in a modest way. So like, so managing money is more important than making money. So I wanted to tell this: if you are not managing your money properly, then even if you earn 1 crore rupee a month, that will definitely go off. Okay, so I want to take this advice, like the managing money is more important than making money. So if you could also take a financial course of how to manage your money and how to make money. So that will help you lifelong. That will help you lifelong, because money solves 95% of the problems. Okay, so I want you to be financially independent. So you could make money by increasing your knowledge and skill set. Definitely by you could make money by your skill set. There are a lot of ways to do that. So this today mindset lesson is about managing money is more important than making money. Okay, so please take any financial course, even though it is not relevant to you on the career part, but it is relevant for your life. Okay, so I want you to take any financial course. So today topic is DC motor control using PIC microcontroller. So in this board, like I'm going to use port D today. Okay, port D. We have eight pins on port D, and this port D is connected to this dip switch. Okay, this dip switch, and I have connected the motor, DC motor, through a stepper motor driver, and to the port pins on port C. Okay, I have used PWM pins. So this is the board which I'm going to use, the same board which I'm going to use today. So in this pin diagram, like if you check in this pin diagram, like I'm going to use port C today, port C of timer 2. Okay, port C of timer 2. So or like 17th pin, I'm going to use CCP1, 17th pin. Okay. So coming to the hardwares, like I need this PIC development board. Pocket Science oscilloscope for viewing this PWM signals, but I don't have right now with me. And I have a stepper motor driver. As well as this, ULN driver, not DC motor. ULN driver, and I have a DC motor. Okay, these are the components required for this project. So why PIC is used for motor control? Like lower system cost, like you have sufficient IOs, and you have like design reuse and scalability. Like the code could be used for the other PIC microcontroller series, and extended product life cycles. You could control multiple DC motors, and like drive a stepper motor with an analog feedback system. So these are the reasons for using PIC for motor control. Okay. So what is PWM? So pulse width modulation. Okay, what is pulse width modulation? Pulse width modulation is a way to control analog devices with digital output. Okay. So if you check, if you see the pulse on this pulse, like you have a on time as well as off time. So on time is where you will get where you will have a voltage. So this on time is called the duty cycle. Okay. So the entire on time and off time will give you the period. So which will give you the period, like the frequency is 1 by period. Okay. So if you check this pulse width modulation, like if you on the right hand side you could see the 25% duty cycle. It means 25% it is on, the rest 75% it is off. Okay. For the 50% duty cycle, like it is on. It is 50% duty cycle for it is on for 25. It is on for 50% and it is off for 50%. So if you use a 8-bit pulse width modulation, so the value will be between 0 to 255. Okay, 0 to 255. And for 55 at middle, like 127, 0 to 127, like the value will be 0 to 127. It's a 50% duty cycle. So 127 to 255 is the next 50%. Whereas the pulse width modulation, what we are going to do is 10-bit. So the value will be between 1024. Okay, 2 power 10. 2 power 10 is 1024. Whereas 2 power 8 is 255. Okay. So the maximum value an 8-bit can have is 255, 0 to 255. So the pulse width modulation, like if you want 50% duty cycle, like you have to write analog write of 127 will give you the 50% duty cycle. Okay. So I will play a small video about the pulse width modulation, and this video was taken from the channel called Simply Electronics. Okay. So I'll play you the video now.
Today, we're going to have a look at pulse width modulation, or PWM. Pulse width modulation has many different uses because it allows us to finely control different electronic devices. In this case, I'm pulse width modulating an LED, which means that I'm pulsing the power supply on and off at a certain frequency and with a certain pulse width. Pulse width modulation allows us to control the brightness of lighting, whether that's a standard bulb or LEDs, or it allows us to control the speed of motors. Pulse width modulation also allows us to make very efficient power supplies such as step up, step down and regulated power supplies, all known as switch mode power supplies. The switch mode in the name refers to the pulse width modulation technique. Now bear in mind that every circuit doesn't run fast enough for me to show you what the LED would do, but in this case the LED would actually dim and brighten depending on the pulse width that I'm sending to the LED. So let's just have a look at the power supply which I am applying a pulse width to. In this case, in every circuit, it's shown in a much simpler form. This would actually usually be some sort of microcontroller that is sending pulses at a certain frequency and at a certain width, turning a power supply on and off. So when this power supply is turned on, it's sending current through to this LED, and when it's turned on, its voltage when it's high or on is 3 volts, and when it's low, also known as off, it's 0 volts. So for every on pulse there is 3 volts and 20 milliamps going through this LED, and for every off or low pulse there is no current flowing through the circuit. In this case it's pulsing every 1 millisecond with a pulse width of 50%. The pulse width of 50% means that current is flowing through the circuit 50% of the time, and current is not flowing through the circuit 50% of the time. So the on time is equal to the off time. If I increase the pulse width to 80%, you can see the result on the graph at the top. Current flowing through the circuit is now on more of the time versus the off time. So the current flowing through the circuit is flowing 80% of the time during the pulse width, and no current flows through the circuit for only 20% of the time. If I further increase the pulse width to 100%, you can see what's happened. Because the pulse width is 100%, current is flowing through the circuit 100% of the time. So there is now no point in time where the circuit is turned off. If I decrease the pulse width to 10%, you can see that the circuit is off most of the time, and only pulses on very quickly 10% of the time. If I change the pulse width to 0%, you can see that the circuit remains off all of the time. The other thing to look at here is the frequency at which we're pulsing this circuit. Currently we're pulsing it at 1 kHz. If I increase the frequency of these pulses, you can see that the pulses get much faster and appear shorter on the graph, although this is still 50% pulse width modulation. It's on 50% of the time and off 50% of the time, but now the frequency has gone from 1 kHz all the way to 10 kHz, and this means that we are pulsing this circuit 10,000 times per second. I can also slow it down by decreasing the frequency. You can now see that the frequency is 502 Hz, which means that this would be pulsing 502 times per second. In this case, when we're pulse widthing an LED, if we pulse it too slow, we would be able to see the visible pulses, which would not be ideal.
How PWM works, okay? And so, which was explained in the previous video, like by switching on the power supply of the device with higher frequency, like we can control the average current flowing through it. So this is how we control the devices. So coming to the duty cycle again, like 50% duty cycle, you have 50% on time and 50% off time. So this is called a PWM period, which includes 50% on and 50% off. If it is 70% duty cycle, you have 70% on and 30% off. Okay, so the resolution, like so the varying duty cycles, like you have on for on and off. Okay, so 10% duty cycle, 50% duty cycle, and this is 90% duty cycle. Okay, so you could use PWM to control basic motor controls like AC motor control and DC motor control, or servo motor and stepper motors. Okay, and special motor control drivers, like you have SRM, switch reluctance motor, and a PMSM motor, permanent magnet synchronous motors. So these are the motor controls available, motor controls you could do with PIC microcontroller. So coming to the PWM module on PIC-16F877A, it has two independent capture compare PWM modules like CCP1 and CCP2. Each CCP module has two 8-bit registers. One is CCPXH and CCPXL that can be used for 16-bit capture register, 16-bit compare register, and 16-bit, 10-bit, and 10-bit PWM registers. Okay. So 10-bit you could store 1024. The value will be between 1024. So PWM channel like PWM 1 and PWM 2, like port C, the pin is port C.2 and port C.1. Like we are going to use port C.2. Like CCP1 con for control register, and the duty cycle register is CCP or IL. Okay, where is a duty cycle register, and period register is a PR2. So I'll explain you again the same thing. Time for which the signal is on is called T on, and T off is time for which the signal is off. Period is T on plus T off. Frequency of the PWM signal is equal to 1 divided by the period. Will give you the frequency of the PWM signals. Okay, so the duty cycle, the percentage of time which PWM signal will be on and high. So duty cycle formula is T on divided by T on plus T off into 100, or equal to T on divided by period into 100. Okay, so this is how these are the calculations, like for T on, T off, period, and frequency of the PWM signals. Okay, so coming to the registers for the pulse width modulation, these are the registers used to generate the PWM signals using our PIC MCU, like CCP1 con, like CCP1 control register, and timer 2 control registers T2 con, and PR2 for timer 2 modules period register. Okay, and CCP register 1 low, CCPR 1L. Okay, which is the duty cycle, which is the duty cycle register. CCPR 1L is the duty cycle registers. Okay, so these are the registers which we are going to use on the code. So these are the steps for configuring the CCP module for PWM operation. The first thing to configure the CCP module is to set the PWM period. Okay, pulse width modulation period. Period is nothing but T on plus T off by writing to the PR2 register. Then set the PWM duty cycle by writing CCP1L registers and CCP1 con 5 to 4 bits. Okay. Make the CCP1 pin as an output by clearing the TRISC. Make TRISC of 2 bit as an output. Set the TMR2 prescale value and enable timer 2 by writing to the T2 con registers. Okay. And configure the CCP1 module for PWM operations. These are the steps for PWM. Like I repeat again. The first thing, you have to set the PWM period by writing the PR2 registers. Okay. Then set the PWM duty cycle by configuring the CCP1L register and CCP1 con. Okay, the fifth and the fourth bit of the CCP1 con, and make the CCP1 pin an output by clearing you have to clear the TRISC. You have to configure the TRISC second pin as an output, and set the TMR2 prescale value and enable, and timer 2 by writing to T2 con registers. Okay, T2 con register. Configure the CCP1 module for PWM operation. So these are the steps for configuring the PWM operation. So coming to the T2 con. So this T2 con timer, the T2 con registers, the prescaler is 4. Okay, in this fifth and fourth, this one, this 2 1, fifth and fourth, the prescale, you have to set this one, like prescaler is 4. So you have to choose 0 1, this 0 1, and CCP1 con. These are the registers like these are the PWM least significant bits which could be used as the capture mode, compare mode, and PWM mode. And these 4 bits could be used for capture, compare, and PWM disabled. Capture mode every falling edge, capture mode every rising edge, capture mode every 4th rising edge, 16th rising edge. Okay, and 11xx is equal to the PWM mode. So you have to configure the CCP1 con registers. The PWM signal generated by the PIC-16 will have 10-bit resolution, which means it could calculate up to 1024. So in order to get the duty cycle 1024, 50% duty cycle, like you have to load 512 into 5, like 1024 divided by 2. Okay. It's 512 for loading the 50% duty cycle to getting the 50% duty cycle. So based on this, whether you need 10% or 20%, so you have to load the appropriate value on this registers. So PR2, whereas PR2 is an 8-bit registers, the timer 2 runs from 0 up to the value loaded into PR registers. Okay, let's go for this is a schematics where the PIC-16F877A is connected to port C.2. Okay, it is connected to C2. It is connected to C2. Okay, it is connected to port C2. Port C2. L293D. Okay, L2, you have to give a supply for L293D. And dip switch interface, like I'm going to connect this dip switch to port D. I will explain you this circuit on the on the video, the board. Okay. So if you check now, if like you could see this port is connected to the switch. Port D is connected to the dip switch here. The port D is connected to the dip switch here, and I have this L293D module. So I could connect this to a 5-volt power supply. Okay, 5-volt power supply, and the board is powered by this USB programmer. Okay, the board is powered by this USB programmer. Okay, so and this is connected to port C second pin. Port C second pin, and the DC motor is connected to the driver. Okay, the DC motor is connected to the driver. So these are the circuits which I have connected. Like I have connected the board. So let's I will explain you the code. I will explain you the code on the presentation, and then we can go for the we can open MPLab and we can go to the code. Okay. Hash include h3c.h is for the compiler for using these high-tech compilers, and hash include pic.h is for which contains the registers. The crystal frequency which I'm using is 20 megahertz, so 20,000. I have put 20,000 megahertz. Okay, and I just declare a run duty cycle. So hash define S1, S2, S3, S5. I have declared seven switch RD0, RD1, RD2, RD3, RD4, RD5, RD6. Okay, so 7 switch for speed control, and a main program. I configure this tris D as input to get the input from the dip switch. So based on the dip switch, I'm going to increase the speed. Okay, I'm going to increase the duty cycle based on the switch, and then I have based on that based on that duty cycle, like the motor is going to I'm going to control the speed of the motor. Okay, as like the video, like if the duty cycle is more, then if the on time is more, then the speed of the motor is going to be high. If the on time is less, the speed of the motor is going to be low. Okay, so tris C2 is I have make equal to 0 is make CCP1 as the output, and this CCP1 con I have loaded with 0C to configure that CCP1 module in the PWM mode. Okay, CCP1 con register. If you take this CCP1 con registers, I have made this as 0C. So see the binary value of the hex value. If you check the hex value of C is 110. Okay, 110, 110. So this one. So 110 is the PWM mode. Okay, if I load this on here, it's 110. You get C. Okay, you get C here. So if I load this hex value, it is on PWM mode. CCP1 con is to configure the CCP1 module in PWM mode, and configure the timer 2 period. So run duty cycle, initially it's 50% duty cycle, it's 512. Okay, I just run this duty cycle, but based on the switch, the duty cycle is loaded. Okay, so initially it is set to be 50% duty cycle, but when it goes inside this one, I configure the T2 con resistors for prescaler before, hence the PWM frequency is set to 4.88 kilohertz, and 4 like enable the timer 2 on equal to 1. Okay, so I'm switching on the timer 2. So here I have a while loop where I load the duty cycle. Okay, I have put the MSB bits, 8 bits in CCP or 1L, and the CCP, or I have loaded the duty cycle. So CCP put the MSB 8 bits. Okay, because it's a 8-bit register. CCP or IL is 8-bit register, whereas duty cycle whereas duty cycle it is 10 bits. Okay, it's 10 bits. So I write shift 2 and I load only the MSB 8 bits. MSB 8 bits, I leave the last two LSB bits. Okay, I put only the MSB 8 bits in CCP or 1L, and CCP1 con and CCP I have loaded bit 4 and 5 as 0. Okay, bit 4 and CCP1 con bit 4 and 5 is 0. This one, this is 0. Okay, and load the CCP1 con as duty cycle registers, assign last two LSBs to CCP1 con. Okay, so if switch 1 is 1, then I load 172. If switch 2 is 1, then if this switch is selected, then the duty cycle loaded will be 172. If this switch is selected, it is 342. If the S3 is selected, it is 512. It runs on 50% duty cycle, 686, 70%, 60%, like 686, 858, and 1020. Okay, so it is on and it is off. It is full on, 1020 is full on, and 0 is full off. Okay, so this is the code. Let's go for MPLab, and we could try this one. I just open MPLab. Okay, I'm going to create a new project. I just click a project, go for project wizard, click next. Okay, pick 16F877A, click next. Okay, click next. Browse, go for the desktop, and I choose desktop. I create a new folder called DC motor. Okay, DC motor. I give a name for DC motor. Click save. Click next. Click next. Click finish. Okay, just go for file, new, file, new. Save this file. File, save as. DC motor. Okay. Okay, so I save this file, right click, choose this file, right click, add files, choose DC motor.c. Okay, and I'm going to type this program. The first thing is to include the header files. Okay, include the header files. I'm going to type hash include. Okay, hash include. So I just go for properties. I'll increase the font size to 22, bold. Okay, apply. Okay. Okay, hash include htc.h for the compiler, and hash include pic.h. Okay, define this crystal frequency. Whatever what are the frequency which is attached in the board, like, okay, 60 20 megahertz. So I just declare a function void run duty cycle. Okay, so hash define switch 1 S1 is RD0. Okay, I just copy this and I paste this. Okay, so I have 7. This is S2, S3, S4, S5, S6, S7. Okay, I make this as RD1, RD2, RD3, port 3, port D. Okay. Okay. So I put a main program. First I will complete the main program. So void main. Okay, void main. So just open the program as well as just close this one. Void main. Make trisd as ff. It means trisd as ff. It means port D as input. Okay, port D as input. Okay, tris TRISC 2 equals 0. Okay, which means make CCP1 as pin as output. Okay, pin as output. CCP1 con equals 0x0c. Okay, configure CCP1 module. This is configure CCP1 module. Okay, configure CCP1 module in PWM module. in PWM mode. Okay, and PR2 register is F of PR2. PR2 is F of timer 2 period. Run, it is 10 bit, so we are making this as run duty cycle as 512. It's 50% duty cycle. We are starting with 50% duty cycle. Run duty cycle. Okay. So now, like, we run the program for the run duty cycle. So void run duty cycle unsigned end, okay, of duty. Okay, first set this T2 con. T2 con is 0x01. It means the set the prescalar value is 4. Set prescalar which is in the data sheet, prescalar to be 4. Okay, to be 4. And T2 con, okay, it's 30. And duty cycle. Okay, duty cycle, shift this. Okay, so assign the last two LSBs to CCP1 con. Okay, then run a total loop if S1 if S1 equals 1, then duty cycle equals equals 172. Okay, equals 172. So just copy this. S2, S3, S4, S5, S6, S7. S2, this is S3, this is S4, this is S5, this is S6, and this is S7. Okay, I make this is 0. This is 1020. 1020. 858, and this is 686. These are all the values, like it gives you the percentage. Like 512 will give you 50% of the duty cycle. 512 will give you 1024. So this will give you the 40%. 342 will give you 40%. Okay. So it loads the duty cycle here. Okay. So the program is completed. Let me compile this program. Let me explain you this program, like htc.h include pic.h. Okay, it's extra frequency of 20 megahertz, run duty cycle. switch 7 switch is connected to 0 to 6 port. Okay, main program port D as input, port C, make CCP1 pin as output, and CCP1 module and PWM module. Okay, so load the T2 con registers. If duty cycle is once, if S1 is 1, then duty cycle is 172. If S2 is 1, duty cycle is 342. S3 is 1, duty cycle is 512. S4 is 1, duty cycle is 686. And S5 is 1, then duty cycle is 858. Okay, so let's compile the program. Trusty. Okay, let me check. Trusty. D. It is trusty. Okay. Compile the program again. Okay, the program is compiled now. I just go for programmer, select the programmer as PIC-2. Okay, so before this I have to on this kit. I will go for the demo mode. So I have to on the kit. Okay, the kit is on now. I also give the power supply to the motor. Okay, I recompile this program. Connect the kit now. Okay, and program this kit. It is programmed. So now I'm going to switch on. I switch on the kit, switch on this dip switch. Okay, so let me verify the code. Like, is RD0, RD1, and RD2. Okay, press D. Okay, so the run duty cycle, like we have T2 con, we have set the T2 con. This actually I make a major mistake. Like this is T2 con. We have to enable the timer. Okay, we have to enable the timer. I'm sorry, like I made a mistake. We have to enable the timer to here, so that the timer to on equal to 1. Okay, so in order to make this timer to on equal to 1, so the next is it should be inside the while loop, while of 1. So CCP, or sorry, we have not load even the CCP or one CCP or 1L. Okay, 1L is the duty cycle, is duty cycle shift of 2. Okay, CCP 1 con. Okay, CCP 1 con making fourth and fifth bit as 0. Okay, making fourth and bit 4 and 5 is 0. Okay, so T2con enable the timer to on equal to 1. Okay, enable the timer to on T2con is 0x01, T2con is 4. Okay, save this program. I compile this, rebuild this program again. Okay, connect this PIC to so here it is. I'll show you the program. So these changes we have to make. Okay, CCPR T2con is enable the timer to timer 1 on equal to 1. Okay, CCPR will duty cycle load only the MSB bits on CCPR1L, and CCP1con is 0xCF. Make bit 4 and 5 is 0. Okay. Okay, I just program now. Let me check. Because some problem. So I placed a backup file here. Let me check for the backup file. So you could see this motor. First, I'll set the duty cycle as 0. Okay, this is the 0. Like the motor is not running right now. Okay, so I'll put this on full demo mode. Okay, so I place this now. So motor started running at. So this is the second speed. Okay. So I'm just increasing the speed now. Okay. Okay. You could see the change in the speed of the motor. Okay. Okay. So this is the low speed. So I'll explain in the code. The same code. This is the backup code. I don't know what's the problem on the previous one. Like htc.h. Okay. I'll explain in the code. These two are the header files. Frequency is 20 megahertz. Okay. S1, S2, S3. S1, S2, S3, S4, S5, S6, S7 are was connected to port D0. Okay. Press D is for the output to make this input. Port D as input. CC pin as output. And configure CC pin model in PWM mode and timer to period. Okay. Run duty cycle. So set the prescalers. T2con, set the prescaler to be 4, and T2con is enable the timer to on mode while of 1, okay, and set the duty cycle. So based on the switch, set the duty cycle. Okay. So with this, let me check what's there in the previous program. Let me check one more time. Okay. Okay. So with so while of 1 CCP or 1L, like load only the MSB 8 bits and make bit 4 and 5 0 CF and load the duty cycle based on the switch. Yes, 1 equal to 1, 172. The duty cycle is 172, 342. Since it is 10 bits, okay, 1024. It should be 1024. If you give 5 to it, it's 50% duty cycle. So 95% on time. Okay, and this is full off. S7 is for full off. So with this, I close the session. Thank you so much for your time, and thank you so much for your time. Thanks for coming, and see you in the next session on Monday.